Alright, let's approach some projectile motion problems here. What I've written out here is a pretty typical example you're going to find for a beginner level projectile motion problem. The main goal here, let me just explain what this is well, a lot of times, especially in class, you're going to see examples of something being thrown or shot or just something being launched off of some height. And then we have a lot of options, honestly, to pursue in regards to a question like that. We can ask something along the lines of how long does it take for the object to hit the ground? We might ask for how high is a cliff. We might ask for how far in the x direction does it go? What was the speed it was launched with? Those are just a few examples of things that we could ask. In this example here, we have a 90-meter cliff with something being thrown off or launched. Let's say in this case, it's like a homemade cannon or something. It's launching our cannonball at 30 meters per second. And the question is we want to know how far away from the cliff it lands. Okay, so that's a horizontal component. And so before we start here looking at equations or anything like that, we need to get our givens correct. And so we'll go over here to our givens, and we first look for position, then we look for given velocities, and then we look for acceleration. At the very end, we see if there's any time factors given to us. In this case, my x's here, I've got an x initial of 0, I'm solving for my x final, and my Vx value here, that's a constant velocity. Okay, once again, there's no acceleration in the x direction on a projectile for these types of problems. In real life, there is a little bit due to air friction, drag, but for our sanity's sake on these kind of problems, we just assume that we're in a vacuum with no air resistance, okay, with uniform gravity. Now, as for our y, there's two pretty common ways that people can present this. Now, you can look at the problem in two ways. You can look at the problem as I'm starting at 0, so my y initial, my starting point is 0, and I fall 90 meters. When I do that, though, I'm assuming that going down is a positive direction. Okay? With my initial velocity being 0, I don't know what my final velocity when it hits the ground is. And since I'm going in a positive 90 meters, then I can make my gravity a positive value. Some people that really messes with them, though, and they're like, well, you're 90 meters up, so you should put your y initial as 90, and you're going to fall to that ground position of 0 meters. So that would be your y final. Your velocities don't change, but if I'm going from 90 to 0, that's a negative direction, and so my gravity would be a negative 9.8. Either one works. You can use the equations relatively the same way. You just need to make sure that you're aware of where your negative is going to be and where your positive is going to be. In this case, though, I'm looking for x final. All right, so there's really one equation in our arsenal that gives us a nice x final equation. All right, in this case, that's going to be our x initial plus constant velocity times time. That's my equation. Now, x initial is 0. I know what Vx is. That's my 30 meters per second. I just need to know my time value here and know how long it takes. In this case, I've already used up all my x information. On these kind of problems, especially when I don't have an angle, many times we'll use the other information, so in this case my y information, to solve for time, because I don't have time. I don't know how long it takes for this to happen. Okay. So usually on these simple types of problems, if I'm solving for something in the x, I'll use my y information to solve for my time. It's not always the case, but that does happen relatively often. And so the equations I have available to me in the y, okay, the same equations that I would have in the x, but we're just going to switch my variables. Okay, I'm going to write out a few of them, kind of discuss why we can or can't use. That's an equal sign, sorry. Why we can or can't use some of these. Okay. Alright, so those are kind of the majority of our generic equations, kinematic equations that we've been using. The real question is that, and why we know we can use my y information to solve, is that as I look at this, when I'm done falling my 90 meters, I'm also done traveling this distance. When I hit the ground here, I'm done falling. I'm also done traveling this direction. So that's why I'm looking at this. Now, let's look at some of these. I can't use this equation to solve for time because this is a constant velocity. Okay? No, that looks like a 2. Sorry, that's a y. Alright. So in this case, that's a constant velocity for here, and it's going to speed up in the y direction. So this isn't a valid equation. Next one here, I don't know what my final velocity is. And second, there's no time in this equation. So that one doesn't really help me very much. Now, as I look at this equation and this equation, both of them have time in it, but both of them also have that final velocity in the y direction. And so that doesn't really help me because I'd have to solve for my final velocity first. So you could take this equation, solve for final velocity, and then plug it into one of these two equations and solve for time. That's totally valid. All right, but in this case, I would rather prefer going to just one step instead of two. This equation right here, I have all the information here except for t, so I can use this one. All right, now I'm going to use this set of givens. This one makes sense to me. I like using positive numbers. All right. In this case, in this scenario, my y initial is 0. My v initial y is 0. Okay. And so I'm left with the y final is equal to 1/2 ay t squared. Okay. And I solve for t, and I get the square root of 2y final divided by ay. That's my equation. So I plug in my values. I do the square root of 2 times 90 divided by a positive 9.8. Let's put our units in here. This is meters. Okay. And we plug that into our calculator. I prefer to do this in chunks. Okay, so I'll do 2 times 90, get an answer divided by 9.8, get an answer. And then I'll do the square root of my answers, and I get 4.28. We'll round it to 4.29 seconds. So it takes just over 4 seconds for it to fall. Then I take this value and I plug that back into this equation right here. Okay, so I drop in my 4.29 seconds there. My seconds cancel, leaving me with just meters as my end unit, so I know I'm doing my math right. Okay, so 30 times the 4.29, and I get a value of 128.7 meters. Okay, and that's how far my cannonball goes. All right, so look over this. The key here is that I want you to pay attention to my process of the givens, and I want you to pay attention to how I eliminate what equations I'm going to use and so forth. Let me just show you real fast before I end this. Let's say you don't like using this list of givens here and you like using this list of givens. If that's the case, let me rewrite this equation. Then when you use this equation, this is going to be 0 now. That's 0. This is still 0. And so what you have is you're going to minus the y initial over and get this. All right? So when you solve for t, your t is going to equal the square root, okay, of 2 times negative y initial divided by ay. Does that make sense? And so there's not much of a difference between the two equations. It's just that now when I plug in my ay, I have to use that negative value so that it cancels the negative up top, so I don't get a negative. All right, that's kind of the reason why I like using this version of the equation. It's just because that allows me to just keep everything positive from the get-go. They're really the same equations. It's 2 times the distance divided by whatever your acceleration is. But sometimes that's hard for people to see. All right. I'll be posting more videos on projectile motion. This is just one example. There are at least I know for sure one, if not several of these on your assignment. So let me know if you have any questions. I'm here before and after school, or you can email me or post a comment and ask questions there. That's fine.